Okay, good morning, ladies and gentlemen. It's New Year. It's already January 1, 2024, and the time is around what time? 12:16. 12:16 a.m. Sorry for that one. I was looking for the clock. Okay, this will be my uh, first lecture for the year 2024, and this will be a random topic, and this is on the topic. This will be analytic geometry. It falls under the so-called discussion of what discussion? This will be under the concept of slope of for a conic section. Okay, let's proceed. I will try to read the problem. This is a random topic and this is under analytic geometry. It falls under conic sections and falls under the subtopic slope. Okay, this is a problem on finding the equation of a line. Okay, a circle with center at -6 and 4. Okay, what is the equation of a line that is tangent to the circle at the points 0 and -8? To visualize the problem, we must have to graph first the circle. And the center of the circle is actually at the location -6 and -4. Am I still on camera? The location of the circle, center of the circle is at -6 and -4, meaning the abscissa of the circle, the center is -6 and the ordinate is -4. So they should be -6, -1, 2, 3, 4, 5, 6. Okay? 5 divisions to the left and the ordinate is actually -4. It should be 4 divisions below the horizontal line. This should be -1, -2, -3, this -4. So the intersection of the ordinate -4 and -6 represents the center of the circle. And it is represented by -6 and -4. The problem is asking what is the equation of a line that is tangent to the circle at the location 0 and -8. At the location 0 and -8, meaning the abscissa is 0 and the ordinate is -8, it is this point here. -1, 2, 3, 4, 5, 6, 7, 8. Okay? The abscissa is 0, meaning it falls under the y-axis. And the ordinate is -8, this point here. So the coordinates of this point here will be 0 and -8. And this point 0 and -8, okay, lies on the circle. Okay, meaning it lies on the circle, it is on the circle. Okay, and the problem is asking what will be the equation of the tangent line over here, meaning tangent line. If this is a circle, the tangent line is actually this line here. Sorry for that one, this one. Okay. The point of tangency is at the location 0 and -8. The problem is asking what will be the equation of this tangent line here. Okay. Okay, let's try to bring out the solution. To bring out the solution, it will be something like this. We will be taking the equation or the slope of the line, okay, the slope of the line that passes through the center of the circle and passes through the point 0 and -8. We will be taking the, what do you call this equation of this? No, slope, because we are given the coordinates of this one and we are given the coordinates of this one. So obviously we could find for the slope of this line here. So upon taking the slope of the line that passes through the center of the circle and this point here, the point of tangency, okay, we can now determine the slope of the tangent line because there is a relationship between this line here and the tangent line. They are supposed to be perpendicular with respect to each other. Okay? The first line is perpendicular to the required tangent line. So if we know the slope of the first line, we could take also the slope of the required line. And upon taking the slope of the required line, by using the point slope form, we could now compute for the equation. Okay, let's proceed with the solution. Let's try to make some designation. We let point P with the subscript 1 will be at the location -6 and -4. This is at the center of the circle. And we will designate point P with the subscript 2, meaning at the location 0 and -8. This is at the point of tangency. It is this point here. So we call this one point number 2, and we call this point number 1. Right? So considering point number 1 and point number 2, okay, if a line passes through these 2 points here, we could compute for the slope. And actually, by definition, slope is actually the difference in ordinates over the difference in abscissa. We can interchange which is first. It could either be y1 minus y2 or x1 minus x2, or we could use y2 minus y1 or x2 minus x2. It doesn't matter. But I will be using the subscript 2 ahead first. So, and now, I will now try to compute the slope of the line that passes through the center of the circle and the point of tangency. So, substituting values, y sub 2 is -8. The ordinate of point number 2. Okay, y sub 1 is -4. So, this is minus, the operation is minus, open quantity -4, all over. X sub 2 will be 0. The operation is minus, open quantity. What is x sub 2? -6. Performing the operation, this should be -8. A minus and a minus, this will become +4. This will now be 0. Minus will be a +6. A -8 plus 4, we are adding two terms which are of opposite sign. Okay, it should be -4 over +6. Or in lowest terms, the slope will be -2/3. Meaning, the slope of the line that passes through -6 and 4 and 0, -8, this slope is actually -2/3. It is negative, meaning it is a slope upwards to the left. So it should be an angle greater than what you call this 90 degrees. Slope upwards to the left, right? This is upwards to the left. Okay? There is an annotation here. The slope of the line that passes through -6 and -4 and 0 and -8 is actually -2/3, right? Okay? And if we try to compute for the slope of the required tangent line over here, okay, since we know the slope of this line, actually there is a relationship between tangent, what I call this, between perpendicular lines. There is a relation of their slopes. And the relation of their slopes is actually given by this one. Right? So I place it there as a second annotation. The required line must be perpendicular at the point of tangency, right? This is the required line, and it should be perpendicular to the first line. And since we know the slope of the first line, by using this relationship, we could also compute for the slope of the required line. So using M1 equal to -2/3, okay, we could now compute. We designate the required line to be line number 2, so this is with the subscript 2, meaning its slope. Its slope now, by using this, will be -1 over M1. M1 is actually the slope of the first line, which passes through the center and at the point of tangency. So this is -1 all over -2/3, performing operation. A negative 1 is just negative 1 over 1, and we change the operation from division to multiplication. We will take the reciprocal of negative 2 thirds, which will be negative 3 halves. So a minus in a minus will be plus 3, and a 1 times 2 will be 2. So m sub 2 now will be plus 3 halves. It is plus. So this is an upwards to the right. As we could see it, this is upwards to the right. And the value is actually plus 3 halves. So meaning to say this is less than 90 degrees. The first slope is actually upwards to the left, and the required tangent line is actually upwards to the right. So I place it there, the slope of the required tangent line is upwards to the right, and the value is plus 3 halves. Okay? So by using the equation point slope form, if we are given a point and a slope, we could determine the equation of any straight line, right? By using y minus y sub 2 equal to m sub 2 times the quantity x minus x sub 2. Why this is y sub 2? Because the subscript of the required line is 2, so I place 2 here. Okay? So, if we could pinpoint a coordinates that pulls on the straight line, we substitute it here. And if we know the slope, actually we could determine the equation of the required tangent line now. So by using y minus y sub 2 equal to m2 times the quantity x minus x sub 2. So we now know why this is subscript 2, right? It refers to the required line. x2 will be 0 at the point of tangency, and y sub 2 is actually negative 8. It was given that at the point of tangency is 0 and negative 8. And the problem is asking what will be the equation of the line that passes through that 0 and negative 8, which is tangent to the circle. Okay? So, by using x2 to be 0, y2 to be negative 8, and the required slope as per computation is plus 3 halves, so this will become y minus open quantity negative 8 equal to, the slope is 3 halves, times the quantity x minus, x sub 2 will be 0. Okay, so this will now be 0. Okay. This, the right hand side is 3 halves x, and this is a minus minus, it's a plus on the right, but we will transpose it to the, no. If it is on the left, it is plus, right? In solving for y now will be 3 halves x. We transpose this to the, what you call this, right? This is a plus, right? We put it in the right of the equation, it should be negative 8. So the required equation will be y equal to 3 halves x minus 8. The equation of the required line will be equal to 3 halves x minus 8. Okay, that's it, guys. This should be a good illustrative example problem on the so-called solving of equation of a tangent line at a given point of tangency. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes. Okay, for those of you who wants to follow my channel is at www.youtube.com/@ProfDavidJ.De If you want to share it, please click share. Okay, good morning from Los Angeles. Happy New Year to everybody.